So welcome to Multi-Agent AI. So this lecture is about AI. We are focused a bit more on multi-agent kind of things, really focus on sort of interactions between different sort of learning machines. So it's quite different compared to if you are in this machine learning related programs, and this is sort of different with other machine learning modules in the sense that we are going to combine with some of the theory from other disciplines, for example, from game theory, and really talking about interactions and what can we learn in a more dynamic environment. Today, what I wanted to do today is that I will start with some sort of gradually start with some sort of background introduction to really to give you a sense what this module is about, and then we were really talking about this our technical detail, some of technical detail today. So this is sort of what I understand, my personal observation on the AI progress. I can find that we started with this 2006, around 2006, people really think about neural network to sort of do so-called classification. So what classification is about is really to sort of to extract knowledge from a given data. So this all started with computer vision, that people try to do this like object recognition, and people find that using neural network really works. And some of these cases that they would argue that have a human level perception. So when I say perception, is like you recognize things. So the idea is that you got this a bunch of data, and you try to find the pattern from the data itself. Then you can think about this as starting point of AI, and then you could come in with two directions. One is that from the perception to decision making. So when I say decision making, is that you rather than I recognize things, extract the knowledge from the data, but rather taking action back to the data itself. So one of the main techniques is called reinforcement learning. And of course, when you plug in this neural network, people actually find that indeed you can solve a lot of decision-making problems. For example, in the gaming setting, people find that if you're using Monte Carlo tree search plus this deep reinforcement learning, you can actually have a very good performance in terms of play some of the games like Go chess. On the other dimension, and you can think about, say, you have one machine, but what if you have multiple machines? Are they able to collaborate together? How are they gonna, interact with each other? So this is the multi-agent system. So when you have a multi-agent system, and things become slightly complicated, is because you need to not only taking off one single objective, you might have incentives, because each individual AI system, they might have their own different goals, objective. How do you calling them together? I think this is really big question. Then combine these two, then they become this so-called multi-agent decision making, right? So the multi-agent decision making is really about when I have multiple intelligent systems, or we call it agents, and each of them try to make a decision based on certain object they wanna optimize. For example, they might want to collaborate together, to play a game, or they want to collaborate together to working on certain, specific, industry relevant tasks, like, for example, navigate, coordinate things in the warehouse, or in the production line, so on and so forth. So this is actually what this module is about is really talking about multi-agent decision making. We think this is going to be very important, a very exciting AI area that AI can contribute. So this is, I think everybody familiar with this, that it is about AlphaGo or later on AlphaZero is making use of deep neural network to solve one of these sort of well-defined decision-making problem, which is Go chess. And here is that you want to sort of make a decision now. That decision would have impact on the future. How can you come up with sort of clever way of doing that? So the underlying technique, as I mentioned, is reinforcement learning. And for people not familiar with, I think we also covered, I think we're going to spend 2 sections on single agent with reinforcement learning, how we can make use of machine learning to do decision making. So in fact, this entire has been modeled as so-called Markov decision process, right? You got this agent and you got the environment, like this Atari game. And then when this agent observe the environment as a form of state, and they would based on that to make a decision. In this case, for example, they observe what's current status of the game and will decide whether to turn left or right. And once they decide to turn left, right, and will basically have the observation whether there's an increased reward or they basically die or something. So then the goal of that is try to maximize the cumulated reward when they try to come in with optimal policy. When I say policy, strategy, meaning that they need to based on specific state of the game and to decide what action they're gonna do. So this is the single agent reinforcement learning. But you do have this so-called multi-agent reinforcement learning. In the multi-agent reinforcement learning, is that this agent not only need to interact with the environment, but also need to take into account the action from others, and their reward and also the environment would not only depend on your action, but also depend on other action. So this is a very generic, what we call the Markov game, right? We formulate it as a Markov game or stochastic game. So it's extension of Markov decision process we just mentioned. And then many interesting, interaction problems like, the video games and, other more practical case can be formulated as, Markov game, and therefore can be solved by so-called multi-agent reinforcement learning. And this which obviously certainly will be covering this in this module. So the difficulty of that is you got multiple agents, then therefore you got multiple incentives. And it's in most of cases they are working in a distributed manner, right? So you probably don't have observation about other people's policy. Sometimes you don't even have observation about other people's actions or states. Then how can you actually, make optimal informed decision? And also the agent not only need to interact with the environment, but also each other. And also the important bit of that is that the change in the strategy of one agent would have impact on the strategy on the other agent. In other words, that when you learn, the other agent also learn. And because the learning environment is not stationary anymore, and then it's because of that introduces tremendous difficulty in the learning. In the later of this module, we will see how we can come with a set of techniques to really solve all these difficulties. So some of these difficulties, in fact, are open challenge even now in this in the research community, and obviously would invite people to really contribute to solve all these difficulties. So far so good. Any questions? Okay. So the multi-agent AI is, as I said, that we're looking at AI systems that interact with each other. Sometimes is also talking about the interaction between AI system and human beings. If you consider, human beings as agent. So our focus really on, because there's a lot of interesting subject on that, but in this module, we are focused on learning problems. And in other words, that we were looking at in those settings, how can a machine would be able to, based on the data, by a number of trial errors, therefore they can actually gain knowledge from the process. So this is what we did a few years back to looking at StarCraft. We did one of the earliest work on this StarCraft AI. Actually, at that time, we beat this Facebook method. So one of the things that also relevant is looking at the communications. So when you're talking about multi-agents system, and if you want to coordinate them, obviously they need to some sort of share some informations. So we actually show using neural network, building this recurrent neural network as a means of communication. In fact, could encourage them to collaborate. They can know what kind of information to transmit to others. Therefore, they can do a better job. So this is just an example to show, in fact, using multi-agent AI, what we can do. And not only in the game, but in the practical case, we also demonstrate, in fact, using multi-agents, you can solve some of our practical problems. So this is the example we show that in this online advertising, you can formulate this so-called real-time bidding, try to put this ads to the right user as sort of a decision-making process. And in fact, if you count these multiple advertisers, they compete to each other in order to put their ads to this end user online, then you can formulate as a multi-agent AI system from the advertiser perspective. In the advertiser, they want to bid certain display opportunity. That display opportunity is offered from one of these users, and then for this user, their previous clicks and their interest. Therefore, this relevant advertiser tend to put their sort of ads there. If this user is likely to convert, then they happy to bid higher. So you could using this sort of a neural network to come in with optimal bidding price in such a way that you could find relevant users and to maximize ROI. In other words, try to maximize your revenue and from revenue from when you try to bid. So in other words, you have a cost, which is the price you're gonna pay to the ad exchange or the publisher, for example, Google, YouTube, or Facebook. But you also have the gain, which is that user saw your ads and they probably convert by your product. Therefore, you can make a profit by looking at the difference between them. So the goal of advertisers, we really try to maximize their, profit by coming with optimal bidding. And then you have a multiple advertisers. In this case, then you can formulate as a competition between advertisers. Then you can, you can then formulate the optimal bidding strategy. So, and you also have many other cases, not only in the internet-based business, but you can also find a lot of application in like a warehouse and in this. So this is a warehouse that we visited a few years back, and one of these on the right top, you can find there's these bots. They coordinate together, try to sort the parcels, and because this number of parcels need to process every single second, then computationally it's almost impossible. You have to do in a disputed manner if you try to coordinate together, and also need to take into account some of these when you do the planning, road planning. You need to take into account some of uncertainty they might have some collision happen. So how do you actually planning then? So this is a typical multi-agent problem. So this is I try to motivate that, and this is the tentative sort of content. And so in the first part of this module, we're going to focus a bit more on gaming. So when I say gaming, it's not video game, but more a game theory kind of a strategic kind of game. To really talking like interactions of each of the agent. Maybe we will start a bit on what we don't call the agent, but rather call a players. And is that we're looking at the game theory, right? The game theory is really sort of study the players. So here, a traditional game theory is really about a study users' incentive, the people's incentive. But these players, in fact, can be like AI systems. In fact, become more trendy to really using game theory to study, machines. So in this case, the machines, the players become agents or intelligent agents by using computers. So then we tend to call these players as agents. So in my module, I wouldn't I try to distinguish them between them, but you could sort of I could sort of say that in the very beginning of this lecture, when we're talking about game theory, in most of cases, we're talking about human beings. But in the later part of this lecture, when we're talking about a bit more on machine learning, and those agents then become sort of a computerized agent. So when we start with sort of basic game theory, talking about various of settings, and talking about how can we actually solve those games. In other words, that the weak version, I wouldn't call it those solvers as learning solutions, but rather how can we actually solve it. But then once that we suppose we don't really know the game itself, then that's the ways where we need to think about learning from the data. Then so instead of know the game itself, but rather we have given some data, and then from the data we can actually given this observation, we gradually sort of learn and try to solve this all this game. Then the learning kick in. So at the later of it, when we're talking about a bit deep neural network, for people who are not familiar with it or haven't taken any machine learning related modules, we would have a very quick introduction about what to mean by learning, machine learning, what is neural network, how can we do backprop to train neural network. With that weapon, and we can go through decision making, which is lecture 6, talking about single agent learning. Once you have some rudimental concept ideas, algorithm, we would starting talking about this multi-agent learning, where we combine what we learn about just a moment, while we learn about this game theory and put that into sort of a introduction of multi-agent learning. And then we could talk about this more advanced version of the single agent learning, and we'll talk about more advanced multi-agent learning.